basically, based on whatever specification it does. And then when you add to the array, if array is big enough, then it'll just keep adding to that same block of memory. If you keep adding and you have exceeded the number of elements that Java allocated for you, whether, I don't know what it is, 10, 20, 100, I'm not sure. It'll create a new array and move your elements to the new array. It'll probably double the array and move the next element in there. So it manipulates the same array as you'd have if you were using just an array, just gives it a little bit user-friendlier, right? So you don't have to mess with that whole allocation, creating a new array, all that stuff. So keep that in mind. Okay, so that was kind of the thing last time. So I just have a couple questions. So array list versus linked list, right? So stuff like that comes up on interviews, and just few questions that I have. So feel free to either put it in chat or shout out. So I'm going to be asking a problem, and then just tell me whether array list or linked list is better to handle that from time complexity. So if you need to write a function or program to examine an integer collection and remove all odd numbers, would you use linked list or array list?
Linked list.
Okay, why?
I think it's easier, it's faster to remove items from the linked list because of the pointers.
Yeah, cool. All right. Excellent. All right. If you were to write a program to go through each element of a numeric collection and insert value after each element that has a double of the value of the element. So go through each element and double the value and insert that value after each element. Linked list or array list?
Array list.
Why?
Because we should iterate. We should use for loop here.
Okay. Any other thoughts?
I would use linked list, I think.
Yeah. I think with linked list is better for manipulating data.
Yeah, so both good points, right, Safi? You're spot on. You're going through that. Your inclination is naturally to use array list. Going through is certainly faster in the array list. But when you talk about inserting, that's where things become a little bit unfit for array list. So that's where you want to use linked list. So it will be better to use a linked list if you're doing a lot of inserting still. So even though you'll save time on looping, inserting into a linked list, into array list, constant inserting may be a expensive operation, because in the background, Java will allocate more memory. The more you insert, the more you'll allocate memory. So, all right, cool. Okay. Let's see, or maybe one more. I have a whole list here. Some of them deal with stacks and queues, so I'm just trying not to ask those because we haven't gone through those yet. Okay, so program to implement a lottery where a random number is selected out of a list of people and that person wins. Linked list or array list? So just you have a bunch of numbers and a bunch of people, basically, hundreds of thousands of millions, and then a program to implement that lottery where you basically have to pick a number out of all of them.
I would use array list. I think it's better for storing and accessing data.
Yeah. Cool. Yeah, absolutely. Because you can basically, in an array list, you can get to element by index, right? So you basically, if you have a program that picks a random number, like, so you have a list of million people and they're all participating in the lottery or some sweepstakes, right? And you pick, 999 as your winning number. So you'd go straight to that, element using the array list because you can get to that location. So okay, cool. Yeah, so that's good. So we covered that. So today, plan for today is to go through two things. We're gonna do again more practice in class, and we're going to start talking about stacks and queues. So stacks and queues are kind of abstract data structures. They are basically the variations that are built on top of array lists or linked lists. They can be built by you, or Java already has implementation. So we'll talk about stacks and queues, what they're good for. Any questions so far on what we've talked last time, and specifically about linked lists, array lists? Is that clear? Good. All right, so you guys want to talk about stacks and queues, or you want to do a fun little exercise in class first?
Maybe let's talk first.
Sorry?
I'm saying maybe let's first talk about our subject, about queues and stacks.
Okay. All right. Okay. Sounds good. So let me share my screen. Has anybody used a stack or queue in this class or anywhere else?
Not really.
No? Okay. All right. So hopefully let me know if you cannot see my screen, but so stacks.
One more. Do you use it at your work yourself? Is it used often?
I don't, because I don't really code, but they're absolutely used, yeah. And we'll talk about some of the reasons to use them. So yeah.
Okay, got it. Thank you.
Yeah. So stacks and queues, right? So stack is what's called a LIFO data structure, and LIFO stands for last in, first out. So this data structure can be implemented using either array or linked list. We'll talk about why use both, but it could be fixed size or dynamic. So when you talk about stack, the quickest way to kind of envision it is by looking at a stack of like dishes, pancakes, or something like that. So it just looks like that. So yeah, obviously this is not how your data looks in the background, but this is just conceptual view. So what happens here is you have a data element. So when you have two operations here, you have a push and a pop. So you push a data piece to your stack, and as you can see, it kind of goes on the bottom, right? So very simple concept. You're stacking your dishes, or you're stacking like pancakes in a restaurant. And when you pop, you take the last one. So that's why it's called last in, first out. The last one comes in, the first is going to be out. So as you can see here, it's a specialized data structure, right? And that's why it's natural to have questions whether you used it or not. So what do you use it, right? So this data structure is specifically designed to do a couple operations really well, and that's push and the pop, right? So these stacks and queues are optimized for just those two operations. The whole point of a stack is the pop and push to be instant, right? Or one operation, because if you have a huge number of data in there, we don't care about inserting. We don't care about going through and all that, doing deletions, insertion. That's not what the stack is used for, and you shouldn't be using it for any of that stuff. The whole point of the data is to push a data, a bunch of things, and then it stays there until you start popping. And as you can see, it doesn't matter if you have a million element, pushing an element is O1 operation, right? Like I have here, because if you have a billion elements, adding one more is not gonna iterate through that billion elements that's already there. Hopefully it's clear. Same with pop, right? Because you're popping on the last element that you pushed. So when you're doing a pop operation, you're not going through the entire stack and looking for an element or anything like that. You don't want to do that. You always take the last element that got in. So those two operations is the core. So you only want to use this stack in places where you need to kind of have that scenario. So again, push is instant, pop is instant, doesn't matter how many elements, O1, time complexity. So you have some, depending on the implementation, you have is full, is empty. Depending, is full basically means whether the number of elements is the same as the number of elements in the collection. So depending on how you implement it, whether you're using array list or linked list, you can have this. Same with is empty. So there is pop by index and element. So this is actually incorrect. This is just pop without anything here. It was just a copy and paste there. So when you do a pop, you always get the one that you inserted last, right? So you don't get to tell which element you want to pop. But some implementations, I believe in Java, allow you to actually say, I want to pop a certain element, which is basically ON, obviously, right? Because it has to go through and find that element and get that out. So the more elements you have, the more that search is going to take. So it's an ON operation because it has to iterate. But shouldn't be using this one. Then if you're using that, then you're probably not using the stack correctly. So this is kind of the object structure in Java. It's belongs to inherit from a vector, and from list, collection, and implements iterable interface, so you can iterate through items. So. All right. So any questions on can you guys think of well, I have a question. Can you guys think of a scenario where you want to use this type of thing in your programs?
Restaurant application or Uber Eats application, for example. There is an order and we would like to execute it. The last order will be executed as the last one. The first one is going to be executed as the last one. So first, how's it called? Last in, first out.
Right.
Yeah. Lethal.
Yeah. Yeah, so let's talk more about that because I didn't quite catch it. So Uber application, what would you put into the stack? Like what type of stuff?
And order, for example, I order some food
Yeah,
from McDonald's, and
yeah.
the application places it, I don't know, inside
Okay.
the how's it called, stack. Yeah.
Uh-huh. I see.
Yeah.
Okay, so
Yeah.
somebody orders, so Uber Eats, somebody orders an item from a restaurant. So
Yeah.
here, and that's why we're talking about, if I'm understanding you correctly, you might actually be talking about something like a queue, because in Stack, so let's think this is your data structure. You put something in here, right? So here, the first person that placed order, they end up here. Second person ends up here, third, fourth, fifth. So you've been waiting for a while here, right? Now, so basically this is your accumulation. So, and I'm sure in Uber and all of those places, they use type of stuff like that, right? So there is kind of a structure to accumulate the data, right? You're pushing stuff in there, but then there is a structure to process, right? So there is some kind of program that gets all of these elements. So if you're a customer and you put the order here and the processing is popping from the top, right? So you're basically putting stuff in and then stuff gets out from the top. The person that actually bought, created the order first is going to wait the longest. You know what I
Okay,
mean?
so I can give you another example, which is immigration services.
Okay.
So there was a lot of immigrants from countries, from other countries, and they decided that they want to get rid of those who applied recently. So they made it the way that the most recent applicants for, let's say, for asylum get they get rid of them first, and then they get rid of other immigrants.
Yeah, I get. Yeah, that would be the structure to use in that set example. Basically, the people that applied, a while back, they're going to be here. So if they want to say, okay, well, we have 1 million applicants, and the people on the bottom have been waiting for a year or something, and we gotta organize it by the application date, and we don't want to process applications for a recent stuff. This would be the way to go. They would go through and take top 100,000 or something. Yeah, perfect. Yeah. Yeah. So yeah, this is basically a way to process as the items come in. Like, it's the way to process those items. The last item that comes in is the one first to be processed in any way, right? Process could mean thrown out. Process could mean actually something is done with it, or anything like that. Any other ideas on how to use this in kind of real world? So anything that, as you accumulate, you want to get rid of the most recent stuff first.
Maybe browser history.
There you go. I actually had that. You read my mind, so I was gonna say that. That's the most. I think I even had it somewhere in the slide deck. So browser history. So as you have the back button, right? So you put it into a stack, right? So think of each data element as a page, right? So user views a page, you put a URL in here, second page there, third page here, fourth, fifth, and when the user wants to go back, all you need to do is take the last one here, and that's your history. Easy way, right? You don't have to have any crazy way to say which pages one prior or anything like that. The stack handles it for you, so you just pop the back button would basically just pop the the element from the stack and throw it out. So cool, good one. All right, any question on this, on the stacks? That's pretty straightforward. So we'll actually do implementation of that in class, right? Not for today, but as a a homework slash working session for next Thursday. We're going to be implementing stacks and queues with the data structures like array list and linked list. So we'll basically have you guys implement that in class. So you'll take the array list or linked list and figure out how to which one to use, so that it follows, I guess, the contract for the stack, right? Push and pop should be a one operation. So you have to figure out which data structure you want to use, so that you always can have append an item and remove an item instantaneously, right? So you don't have to go through the data structure. So start thinking about that. And the close cousin of the stack is the queue. So let's talk about the queue a little bit. So I think somebody already mentioned, a data structure where you kind of have orders, right? So you have a bunch of things coming in from all directions. So Uber Eats orders, and then you want to, so basically think of it as a line, right? Like a customer line in the store. So they all line up, and that's literally the queue. They call it like a line or a queue, and the person that he enters first or place an order first or anything like that is the one that's served first, right? So that would be your Uber Eats example, that the queue will be your friend here. So very, very similar kind of structure. It's a linear, could be implemented with array list or linked list, and again, could be fixed or dynamic size. And unlike LIFO, last in, first out, this is a first in, first out data structure. So you get, you're in the front, right? That means you're in first. And then when you in the front, when processing happens for this data structure, DQ is the name of the method. You are basically served first. So typical line. Okay, so this one also has queue and DQ, unlike pop and push and pop in the stack here. It's called queue and DQ. So queuing is in queue or in queue is basically adding an element. If there is no elements in there, it'll be first, and then they kind of line up. And then DQ is removing for whatever reason. All of those, both of those are O1 operations. So in which, again, the structures are optimized for these operations: Q, DQ, and push and pop. That's the whole point of having these things. In queues, there is a thing called peak, and I believe stacks have that too. Most stack implementations have a peak. So what peak does is you basically look at element that you're about to remove without actually removing it. So In here, you'd be, instead of the pop, you call it pick, and it just returns the element on the top of the stack, but it won't actually remove the element from that stack. Here with the queue, you can, call it pick, and you get the element, but it's not, the queue is not gonna get rid of the element. So it could be useful, for example, if you look at the element, you may look at certain conditions before you processing, right? And you look at the element, and you may, there could be some property of the element that you don't want to process that, but you don't want to remove it either. So it's just kind of a way to look at what's next without actually, making an effort, taking an action on that, or without actually changing the contents of the queue. So that's the peak. Cool. And then is empty is full also there. So what do you guys think are some of the use cases, more use cases for the queue data structure on top of the Google or Uber ordering?
Maybe this line system in DMV.
Sure. Although it's really slow queue, right?
Yeah.
Okay. Yeah, absolutely. Any type of I guess reservation things, right? So you basically have, or any type of like you have a, yeah, like a line reservation system. People are making reserving things, and those orders would get into a queue, and you kind of process anything where a lot of people are taking action, and you want to reward people that took action first, right? So you want to kind of put them in based on the obviously when they took action. So you queue all those elements, but the DQ happens based on the order in which they took action. So tons of things there. So maybe you have like a sale, right, on the items. Maybe it's Black Friday in Walmart, and they have their application, or Amazon Prime, and you know how those sales run out, right? You have items that you just run out of, but how on like Black Friday or Cyber Monday or something, people just go and start trying to purchase stuff, and sometimes you just don't, even if you purchase, they'll tell you the item runs out, it's not available. So they have a discount maybe, and they'll put people in a queue on the site, and then until they have items, they'll process in real time and get people checked out. And then once they run out of the element, the item, they will tell the people in the queue, hey, we'll get back to you, right? So you want to preserve them in the line. You may say, hey, we will get more inventory and you'll be contacted, that type of stuff, right? So you kind of preserve the data structure in the database or something like that, so that if you want to be good to the people that went in and tried to purchase it, but you run out of items, you kind of have that queue of of purchasers in there. And then when you finally get those items in stock, you'll get your queue and start dequeuing again. You preserve the place in line for each of those people that didn't get to buy an item. So, but very, very powerful data structure that's used a lot any applications that deal with a lot of data and first in, first out logic. So yeah, so we talked about the operations, but this is different types of queue that exist, and based on the implementation, based on the underlying data structure. So as you can see, linked list, remove O1, right? And basically, I think some of this DQ. There are things like priority queue, some more complex stuff here. We don't need to worry about that, but we're going to be talking about linked list and array list implementations only. So any questions on either one of these, stacks or queues? Pretty straightforward. I assume you guys haven't used either of them yet, right, in your programs?
Yep, never used, so that's why we don't have much questions.
No, that's okay.
Igor, I have a question.
Sure.
Is it gonna be on the interview questions also? This kind of things?
Well, I don't know who's going to interview for what company or what role. The general data structures are always on interview questions for any company that deals with a decent amount of data. So it's highly possible. Yeah, not as probably not, the probability is a little lower than getting questions on linked lists, array lists, and all of that list type of stuff. But stacks and queues are also, especially queues, are very popular. So good probability.
Thank you.
Mm-hmm.
Igor, is it useful for automation test framework?
For automation test framework, huh? Well, I mean, I don't know. Maybe you guys can tell me. Is there a scenario where you need to, you have a bunch of things that you want to kind of collect and then process them based on, the priority, based on their, like, first in, first out, like a queue, or last in, first out, like a stack. I don't know. I guess there will be, but I can't think of anything concrete.
Okay, we'll see in future. I get it.
Yeah, I don't know. I'm sure that there's going to be some, but what the actual coding exercise that we're going to do with this stuff is going to give you more practice with linked list and array list, which is really the core stuff. So you're going to be basically designing your queues and stacks in a way that you will have those pop and push and queue and dequeue methods implemented so that it's O1 linear time. So no matter what, you're going to deal with lists, and that's going to give you even more practice with lists. So, which is really the core of core data structures for queues and so there is no, like, Java doesn't have a separate data structure for queues and stacks. There's no, like, separate data structure. It's all lists, array lists, linked lists. So linked lists or arrays are in the background there. So it's just an implementation. All right, so we going to, so then I'm kind of looking for the rest of the stuff we have. So we'll probably deal with queues and stacks next time in terms of logic. So I wanted to make sure you have time to implement stuff and keep practicing, right? This thing is going to be useless unless you guys write code. You're going to forget it all. So that's why it's very important to do these exercises. And what you're going to see on the interviews is more exercises. So, they're not going to ask you theory like, oh, what's, what are stacks and queues and lists. They're going to give you more stuff to do and ask you to implement it using arrays, lists, and all of that stuff. So that's why I really push you to do this stuff rather than know about it. Both are good, but practice is the key. So that's what we're going to do today. More of that today. I think we have enough time for this. Let me share my screen and I will go through this. All right. Okay, so write a method, call it whatever you want. I call it mark length 4 that takes an array list of strings. So takes a list of strings as a parameter. And then places a string of 4 asterisks, so 4 little stars in front of every string that has a length of 4, right? So you have an array and you have a bunch of strings in there. You go through an array and you figure out which strings have a length of 4, right? Like this array, this is lots of fun for every Java programmer. So you guys are gonna love it. And once you're done with it, you're basically gonna go and say, okay, this word, literally this word, has 4 characters. So you need to place 4 asterisks in front of it. So basically the output would be 4 asterisks in front of this, right? And then you move forward and say, okay, lots also has 4 characters. So you need to place 4 asterisks in front of lots. And the Java, our favorite word, has 4 characters. So you go and place 4 characters in front of the Java word. And that's going to be your output. So leave the original strings in the list, right? So you're not replacing this 4-letter words with 4 asterisks. You are just inserting that in the front. How cool is this? Any question? That's a typical interview exercise. Doesn't get any more interviewee than this. I'm gonna post this in the chat. Is this clear? Well,
Yep.
all good. So think of what data structure you want to use. So it's in the CodeWell channel. So think about the data structure you want to use for this. So you're going to be getting, the function will take a list of strings, right? Array list of strings. You can change it basically based on what you want to use for this, right? So you don't have to use array lists. You can use a linked list. So whatever you I just wanted to clarify, it takes an array list, but you don't have to use array list. So if you want to use linked list for whatever reason, use linked list. That's as based on kind of what's your perception of the maximum performance would be. Okay, so I pasted that. How much time do you guys think you need to you need for this? 15 minutes, 20 minutes, 5 minutes?
Let's
Like-
start with 15.
15 would be fine.
15? I like that. All right, cool. So 4:50 now. Let's come back 5:05 or something like that and take a look. So the most elegant solution wins the Java Programmer of the Day title. So, all right, I'll be here to answer any questions. All right.
Okay.
All right, so how are we doing?
Okay.
Who wants to demo?
I mean, I can try. Not sure if it's right, but it's working.
It's working. It's already 90%. So, go ahead.
Can you enable sharing?
All right, should be good.
That's what I got.
Cool. Yeah.
Can you see it okay?
Good.
So I just add all the words one by one. I'm not sure, is there a better way to do this, or that's...
Not that I can think of. I don't think there is a no.
Can you do like something like collections that at all?
Maybe, I don't know.
Okay.
I don't
think
really know every method in Java, so possibly.
Yeah,
I mean,
I created the for loop, which I was using for indexes of
yeah.
the words. And if they match a length of 4, I just replace them with the 4 stars and just return a list back.
So
There is, yeah, and there is in your output words this.
Oh yeah, this is.
Yeah.
I thought it was a little bit too simple.
Mhm.
So the problem is you are replacing, right? So you're replacing the words you should insert that asterisk prior to each of the words that have 4 characters. So good start, but take a look at the actual problem, right? So notice that you leave the original strings in the list. So this lots Java should remain there, but the 4 asterisk string should be in front of it.
Oh, okay. I see. All right.
So a few more lines to add, but
okay.
good start. Okay.
Thank you.
Who else has it working? Are you guys still working on it, or is it?
No, we're done. I guess we're just try. Mine is not really fancy. It's almost the same as Petro's.
Yeah, let's take a look. Don't be shy.
Can you see my screen?
Yeah.
Yeah. So yeah, this is the method.
Yeah.
It returns a list.
Sure.
We take array list as a parameter. If the string, the list is empty, like there's no need to iterate through it, we'll just return it untouched. And yeah, I used linked list, but like thinking about it, maybe there was no point to do a linked list. So yeah, anyway, iterating through the list of strings. If the length is 4, then we adding this. And then we also need to add all the elements and just return the modified list.
One second, for if element equals 4, modify add. Okay. And then you add the element after that. All right. Cool. I assume that works. Yeah.
Tested it with 2.
Yeah.
Didn't test with any negatives, so don't know.
Yeah. Really cool. So yeah, you looks like you use a linked list so that insertions are quick, right?
Yeah, but I'm still inserting at the
Oh
end,
yeah,
right?
yeah,
Like it
yeah.
doesn't even matter if I'm using linked list or array list.
Yeah, fair. Yeah, it doesn't. It doesn't really. If it's you're not manipulating kind of a big list that's that's already intact. You're not deleting and inserting in the middle, so it's
Yeah.
doesn't really matter. You just okay, cool, very cool. So, all right, anybody else?
I posted my on the code well. You can check. I'm not sure if it's correct, but it runs fine.
Let's see. Oh yeah, I see it now. Okay.
I think it inserts elements, those asterisks, before each even.
Oh yeah.
Set of characters, not
Yeah.
before length 4.
Yeah, that's what it does. Looks like it's every other element. So so you have that you check in for even numbers basically. Yeah.
Oh, I thought that was the requirement. Okay, then never mind.
Only the ones that have four characters. So yeah, but you're well on your way. So just tweak it a little bit to get it to the. So. Cool. Well, so that's one thing I wanted to, as we're working through these exercises, and you start your interview process, and pass the interview, start your development. It's one thing that I want to reemphasize: do not rush, right? With kind of getting through that, because it seems like some of the problems on the interview will be quick, but you know what? Sometimes happens is they make it the devil's in the details. So read each problem 2-3 times, right, slowly, and make sure you understand the full logic, so that you're you don't rush with that stuff. That's key point. That's one of the things that we're learning here, right? Better for you guys to learn here than at an interview or at a job. So reread it, reach requirement. We'll actually go through that too as part of this class, and kind of towards the end. And we're going to talk about interview prep a little bit more detail. So I'm gonna talk to you as we kind of will have gone through the data structure, good coding practices, and we'll even cover some algorithms. So you'll know some of the algorithm stuff. So you should have enough basis for not only passing a successful interview, but also coding, whether you're going to be a QA engineer or you're going to go for software engineer. You should have a really good base based on the knowledge that's I'm giving you. But so we'll talk about kind of how to approach the problems at the interview. So there is a kind of structured way to how you want to approach it, and big part of that is actually understanding, rereading the problem several times, making sure you kind of break it down. And because you're gonna have some pressure, right? It's stressful for on the interview. You go in, and no matter how confident you are, still when somebody is like looking at you, or you have to do something coding wise in front of somebody, it's stressful. So important thing will be to kind of take a step back, slow down, break the problem. Sometimes it's even good to restate the actual problem to the interviewer, right? So you'd basically say, okay, so if I understand you correctly, you know, I need to write a program that does so and so and so, right? And there could be some things that you may assume, right? Like maybe the input or something like that, you may want to clarify as well. So output or anything like that. So if you are assuming something, would be probably good to also you know, state that back to whoever is interviewing you. So I assume I'm going to use this, or I'm going to use this data structure, or I assume the input is not going to be empty. So because sometimes you kind of, you know, assume that you're going to have an array of strings. And if your array is empty, your program is going to crash, or, you know, or something like that, right? And the interviewer may think, you know, it's actually a bad thing if you didn't either ask or checked, right? Like, okay, you know, I'm going to account for that in code. If, you know, there is no items, I return that array. So somebody already did it pretty good. So, or sometimes it could be nothing, right? They won't care for that. But some interviewers are just detail oriented. They say, you know what, you know, the developer should check for all conditions. So it's best to just kind of check. Do you want me to check for null input? You know, that type of stuff. Just a few pointers. Or all right. So any questions on this? Was this simple to do, or how did this feel? You guys had, you know, went through this easily, or is this, how long do you think you'd need to do something like this? Was 15 minutes enough, or you need more time for something like that?
With a little bit more of practice on that, 15 minutes should be enough.
Oh. Cool. Yeah. All right. Yeah, I'm just trying to gauge your kind of progress and how you guys are, how much time it takes you to solve these little bites. So just let me know. All right, so for next class, what we're gonna do is, so I have a bunch of things for you, right? So we want to talk about, on Tuesday, we're going to talk more about abstract classes, interfaces, and that type of stuff. So, you know, I promised I'll put together some more examples for you guys to kind of solve for. So please try to do that by Tuesday. I'll post it by tomorrow or something like that tomorrow. So you have weekend, just take a look at it. We'll have a discussion in class. So hopefully we'll get a little bit more clarity around abstract classes, interfaces, all of that stuff. So critical thing. Without that, you will be lost really in Java. So because as you know, everything in Java implements some type of interface or you know, subclass, all of that stuff. There's dependency injection everywhere. So any object-oriented language relies on those concepts. And then for this, I'm going to also post homework to implement a linked list based or array list based queue and stack. So maybe we can, I realize that's a lot of homework and you guys are busy, so do what you can. And what's going to be left, we will, you know, continue doing in class. So a lot of practice, but it's needed. So. Cool.
Sounds good.
Thank you so much.
Okay. Well, good luck with your next class. Thanks. Bye.
Thank you, Igor.
All right, bye.